This is the introductory video for the Electromagnetic Induction and Faraday's Law experiment for Physics 1102-1220. So this is the equipment we're going to use. We've got a signal generator here, which is going to drive a current through the first of two coils of wire. So the signal generator drives a current through this. That creates a magnetic field, which is going to be picked up by this coil, which will also drive a current through it. And we're going to look at the voltage that the electrons in each of these two coils feels on the oscilloscope. Now, before you begin, you're going to need to measure a few quantities. One of them is that you want the resistance of this coil here. And there are actually 3 pickup points on this. And you'll notice that our wires are hooked up across the outer 2. That's so that we're also including an internal resistor as well as the coil itself. So your signal generator here should be hooked up across the 2 pickup points, and you want the resistance of all of that. So you would grab your digital multimeter and also plug in across here and measure the resistance of everything. So that's one of the things you need to measure. Another thing you need to measure is the diameter of the coils. So you just grab a ruler and measure this, but you need to measure the diameter for both of these coils individually, because this one only has 200 coils of wire and this one has 500. So this one's quite a bit thicker in terms of where the metal is. So there's holes in these brackets here, and you can get in here and try and measure overall what the diameter of the metal coils of wire are across here and separately across here. And you want to think about the uncertainties you choose, because as I said, there's a lot more wire on this one than there is on this one. So you'll have a larger uncertainty on this one than you will here. So as accurately as possible, measure the 2 diameters, and you also want to measure the distance between your 2 coils of wire. So a good way to do that would be from one edge of one bracket to the edge of the other one. I actually prefer to do it down here where it's a little more stable, just because these are a little wobbly. But you'd go from the front edge to get your distance between them, and that distance should be fairly small, so somewhere between 5 and 10 centimeters. So we're almost ready to turn things on now, but there is one more thing to check. So the manual tells you that there is a resistor over here on this second coil of wire as well. Just make sure that it's secure in there. But assuming it is, now we can turn on the oscilloscope. And just a reminder that channel 1 of the oscilloscope is hooked up to coil 1, and channel 2 of the oscilloscope is hooked up to coil 2. Another thing you should think about is what direction are we actually running current through this first coil in? And what direction is the magnetic field going to point? That direction or this direction? So work that out. Once your oscilloscope is warmed up, you should see both traces on there, yellow and blue, and you should set up your oscilloscope using the settings specified in the lab manual. Then you can turn on your signal generator. Should just need to push this button here, but if it doesn't come on, there is a second switch over here at the back that may also need to be turned on. So let me show you how you change settings on the signal generator. So this is the front of our signal generator, and they tell us that they want us to set it to a square wave with frequency 100 Hertz and amplitude 5 volts peak to peak. So down here, right now it's lit up with the sine wave function. You can see that here. So we can go to square wave or ramp, which we'll use later, and various other settings. So we go to the square wave to begin with. And right now we're set to 1 kilohertz, and we want it set to 100 hertz. So we need to go down from here. You'll notice that one of the digits is in black, and I can change which one that is by pushing these buttons over here. So I can go to the 100 hertz column, or the 10 hertz, or the 1 hertz column. And so I'll go to the 100 hertz and then dial this down. So 900, and I want to go to 100 hertz. I also want an amplitude of 5 volts peak to peak. And one thing you'll notice is that there are these buttons along the bottom edge here. So the one that's currently highlighted says frequency, and there's one right beside it that says amplitude. So press on that, 5 volts peak to peak. We also want an offset of 0 volts DC, and the duty cycle should be 50%, and the phase should be 0 degrees. And then I'll go back to frequency. So that's how you set up the signal. Now, as you do this, one thing you may notice is that nothing on your oscilloscope is changing. That's because you have to actually send the signal to the output by pushing this button. And as soon as you do this, you should see something show up on your oscilloscope. In fact, you'll see something that kind of looks like this. So as usual, feel free to use the auto set button to get things looking nice quickly. And it's a good idea to change your time scale so that you're seeing fewer oscillations. They want you to sketch what you're seeing here accurately on graph paper. So that means 1 box on the screen equals 1 box on your graph paper, Or if you've got a data stick, and I believe it needs to be less than 8 gigs in total, but if you have a data stick that small, you can plug it in here and save your image. Or if you've got a smartphone, go ahead and just photograph the screen in high enough resolution that you can read all the settings on it, and then you can put that in your notebook later. Now at this point, they ask you to answer some questions and play around with things a little bit. So for example, they ask you whether the output from coil 2 is doing what you expect it to based on Faraday's law. They also want you to vary the DC offset on your signal generator, like this, to see what it does and how it affects both of the signals. And they ask you to change the frequency, and again, say how it affects both signals. Finally, they get you to switch to a triangular-shaped wave. So it's called the ramp wave on your signal generator, and it looks like this. And this is actually the one that we're going to be using to take data in this experiment. Of course, you'll notice that coil 2, the signal doesn't look very interesting right now. You do need to increase your scale in order to see why this is interesting. So once you've done that, you can start to see the effect that that sawtooth wave is having on coil 2's signal. And again, they'll have you change the offset and the frequency for this wave as well, and say whether it's in keeping with what you expect from Faraday's law. After you're done doing that, you set your signal generator back to the settings specified in the lab manual, and you're ready to take data with your coils. Now, all you're going to be doing to take data in this experiment is changing your frequency from 100 Hz to 200 to 300 and so on, and seeing what effect it has on coil 2's voltage. So I could show you the whole setup like this, but it makes more sense to zoom in on the oscilloscope again to show you what effect the data taking has. So you're going to be making a graph of two quantities for this experiment, and one of them is just going to be the peak-to-peak voltage on coil 2. So you'll use the cursors to measure these. The other thing you need, however, is the slope of this line, of this sawtooth wave on coil 1. So how do you get the slope of this? Well, you could use the cursors to figure that out, because the slope of a line is just rise over run, so you could figure out the position of these 2 points. But this is actually something that can be calculated pretty simply. So again, slope is rise over run. The rise of this is 5 volts peak to peak. We already know that. So we just need to know how much time it takes to get from here to here. And you can figure that out from the frequency that we set on our signal generator. So the frequency right now is set to 100 Hertz. So that means the amount of time from here to here is 1 over 100 seconds. And then the time from here to here, the halfway point, would just be half that. So that's one of the quantities you need, is that slope. And as I said, the other one is just going to be the peak-to-peak voltage on coil 2. So because we only need to take measurements off of this blue line, I'm actually going to turn off the yellow one for now. And I'm going to move the blue one up to the center, like so. So again, we're going to measure things with the cursors. So I'll press the cursor menu, and one thing that you want to choose is that the source is channel 2, so not channel 1. So now it's set to channel 2, and the type will be amplitude. And we want to use the cursors to figure out the peak-to-peak voltage here. So you know how to do this. You'd move one cursor down to the top of that signal, switch to the other cursor, move it up, and then read off your voltage difference right here. And it will be a small number, usually in the millivolts. So that would be your reading for the 100 Hertz, and then you'd turn up the frequency on your signal generator to 200 Hertz, and then you want to measure this peak-to-peak voltage as well. So again, adjust your cursor positions and read off your voltage difference here. And you'll do that from 100 Hertz up to 1000 Hertz. Then you're going to be using your values to make a graph of the slope of that sawtooth wave versus the peak-to-peak voltage on this wave, and the slope of that graph that you make is one that you can compare to a known theoretical value.